I'll do some recording. So before I start the topic, the main topic tonight, I would like you to copy the following link of the Zoom, because per the last tutorial experience, there is the time limitation. So when the first, right now we are on the first, maybe I share my screen. Okay. So there are three links. Please copy it down, because when the first link, right now we are using the chat room. After I think 40 minutes, it will cut our chat room, and we need to enter again. But sometimes we may not be able to enter the same chat room. So I have create two more chat room. Once we are stopped by the first one, then we all go to the second one and the third one. Okay?
Okay.
Okay, good. So tonight, as I know from Mr. Demopoulos, you are going to take quizzes in the coming Thursday, right?
Yes. Yeah.
So I would like to make use of tonight to go over some of the highlights. But firstly, I would like to declare that I don't know about the quizzes. I don't know the question, but I just would like to go through some of the critical points, like the emission calculation. That is William, Mr. Demopoulos would like me to present you all again how to calculate the emission calculation. And then we will take a look on the power factor. And we also concluded with the Q-sum and regression analysis. You may say in the quizzes, it is not possible for you to switch on the laptop and open the Excel and do the programming. But you may receive a graph or a data table, then ask you some of the questions. But I would like you to know about some fundamental knowledge about regression analysis and what does it stand for, and what is the procedure when you receive a bunch of data like HDD, CDD, energy consumption, how you handle this. So at the end of the tutorial, I will do a demonstration on the Excel spreadsheet. Okay? So for our first topic is about the emission calculation. For the emission calculation, as I remember, is the knowledge, or is the content in the first lecture. Does anybody still remember what it is about? No?
Sorry, what do you mean to say?
I mean the emission calculation. As I remember, because in your first lecture, I also watched the video, the lecture video, and I knew that this content is happened in the lecture one, your first classes. So I just asked, did anybody still remember what is the emission calculation? Okay, never mind. Just do some warm up. Yeah, just do some warm up. First, if you still remember, there's a graph and tell you what is the greenhouse gases. So eventually, there are many types of greenhouse gases, like in this figure: methane, carbon monoxide, carbon dioxide, ozone, sulfur dioxide. Those is counted as the greenhouse gases, but it will have a different wavelength, and you can obtain to affect the global warming. And it is showed in one of the figure. Later on, I can open the file of the lecture 1 and let you refresh your memory what kind of greenhouse gases is about. So about the calculation, right now everybody will say the target 2050 to have the carbon neutrality. But before we achieve this, we need to know some of the target. If I need to achieve carbon neutrality in 2050, what should I do? And what situation we are now? So it's very important to know for every activity, you will create some of the greenhouse gases. And those greenhouse gases, how we can standardize and present what is level it is. As in the previous slide, you will know not only carbon dioxide as the greenhouse gases, there are any other which may cause the greenhouse gases. So in the industry, we have a standardized method to obtain this number. So tonight, we are going to review how we do the emission calculation. Before we know the equation, first, we need to know the activity. How we know the activity in your daily life, like from your electricity bill, your natural gas, your gas bill, or even you go to the gas station for your car, they also have a bill. And in your bill, it should clearly state that how much energy you consumed, how many energy you consumed, neither the unit in kilowatt hour or gigajoule or gallon or liter for your vehicle. It is what your activity will consume the fuels, and the fuels is a kind of energy. So they have a different unit, okay? So after you obtain the activity data in terms of energy amount, like what we present the kilowatt hour, another factor you need to know is the emission factor. So this factor is a ratio corresponding to the amount of the greenhouse gas emitted per the activity energy use. So in a simple word, that is, when you do something, how much greenhouse gas you will create and emit to the atmosphere. So normally, it will give you a unit of the in terms of a gram of carbon dioxide per the energy unit. So in the table at the right hand side, the density factor you can see it is for natural gas, 1 cubic meter, how many energy is an energy density factor. But another we call the emission factor, that is how many carbon dioxide emitted per gigajoule. Okay, this table I just simply extract from your lecture notes. So that means you have already have this table, but you need to know with different fuels type, there will have different density factor and also the emission factors. Those two factors will determine the emission. Okay, just give you some idea on what we are going to do. So far, any question?
Good to go.
Okay. Any
Yeah.
question?
No.
Yes, no, okay. So this table gives you a very fast check and very brief concept on how to calculate the emission. Like the propane. Propane, that means when you cooking, sometimes you will consume the propane. So of course, 200,000 liters is quite a lot. But assume you are doing some industrial process. You consume 20,000 liters. And for this propane, the density factors is 0.025 to 1. If I know the amount of the energy, the fuel consumption amount, and also the density factor, we know the energy. Why we can do it? Because try to remember, the density factor is kilojoule per meter cube, and for propane, that our example is gigajoule per liter. And in our example, we consume 20,000 liter, and every liter we need to have 0.02531 gigajoule. So by multiply 20,000 and the density factor, we can obtain the value of the energy in terms of gigajoule. So in this step, any questions?
No.
Okay.
No.
Okay. So that is the first part of our calculation. The second part we also need to know is about the emission factor. That means in terms of the unit is how many kilogram or how many tons of the carbon dioxide we emit per 1 gigajoule. That is the number in this table. So we get back to our example. This factor is 61.15 that we can obtain in this table. And when you know how many energy you consumed and what is the emission factor, by multiply these two numbers, you can obtain how much carbon dioxide you emit in the atmosphere. So any question on that? Is a whole and simple brief calculation on one fuel's consumption. Any question?
No.
No, that's good.
Okay. So for another two, electricity and the gasoline, it did the same. Just refer to the table and do the same thing. And with the same methodology, you can also obtain the carbon dioxide, the emission, I mean. Okay. So actually, what I trying to do is for every, that is another table, which would tell you in the previous calculation, we all obtain in terms of carbon dioxide. But sometimes you will refer some of the textbook, it will tell you for propane, it will have this certain amount of carbon dioxide, this certain amount of methane, this certain amount of nitrogen oxide. So those information can help you to calculate the emission with this combined emission factors. So let's see one more example. 10,000 liter this time is consumed for the propane. And we know for carbon dioxide, the emission factor is 1,515. And this number, we multiply the activity, the fuel's consumption, we can obtain different value of the emission. But it is not only the carbon dioxide. It will have a carbon dioxide, it will have the methanol, it will have a nitric oxide. So those numbers we can summarize like this. But now we obtain carbon dioxide, we obtain, there is a different element and different compound we obtain, but it's not standardized. So we need to employ a concept of the global warming potential, GWP. As I remember, it also have the definition in the lecture notes. And with GWP, what is GWP is they take carbon dioxide as one unit of the GWP, and corresponding with different compound, they will have a different ratio number. So as in this example, we have these three figures on these three different compounds. We can simply make use of this ratio and standardize all the emission into the carbon dioxide. And just one outcome we'll have is the carbon dioxide. Okay, so it have another idea on in a real situation how we calculate with the emission. So any question for this?
No.
Okay, good. This is a very important slide because this slide is prepared by Mr. Demopoulos. So Professor does not test using more detailed method. So what I try to present about different compound is for your reference. But most importantly, you need to know one convention is 1 gigajoule, how many kilowatt hour. That is very important. And even you, when you study another subject, you also need to understand and remember this convention. Okay? So that is the first part of the tutorial about the emission calculation. Any questions?
No.
Okay. No. I would like to go for a little bit on the lecture notes on your first lecture, but I would like to clarify that the thing I would like to I'm going to talk about doesn't mean it will appear in your quizzes, but I do believe it may is quite important for me. So I just would like you to understand and know some of the pages. So first, I think these pages is very essential because when you do your calculation, sometimes I've seen some of the people like to use such kind of presentation in the number, like 1 million kilowatt is not very good. I can say it's bad because you can make use of gigajoule, terajoule, petajoule instead of 1 million kilojoule, some of the idea like that. So in some circumstances, you need to know how you present gigajoule, how you present terajoule, how you present petajoule. Okay? Because when you finish your lecture one, I also review the video again. I think this graph is also important because as you greenhouse effect, greenhouse gas always will have a very important topic, but somehow you need to know how much radiation, solar radiation, is reflected back to the sky, leaving, how much is absorbed by the atmosphere or absorbed by the earth, the surface. Some idea you need to know about that, I believe. And this is what I mentioned. Greenhouse gas is not only carbon dioxide. There still have another gases, but it will active in different wavelength. I think this is, you need to understand what is it about. So for the global warming potential, that's GWP, that I have explained in the last question. Because there are so many type of the greenhouse gases, in order to standardize a unit, so we simply take the carbon dioxide as the standard one. And with different gases, there are different ratios. That is the GWP concept. So this density factor and emission factor, that we have already used this in our calculation. And this is very important, as Mr. Demopoulos also have created a slide and try to remember and understand 1 gigajoule is equal to 277.78 kilowatt hour. Or simply, you may easier to remember 1 watt hour is equal to 3,600 joule. It's up to you. So I think that kind of information you has already known. But sometimes for the chart observation is also a kind of facts you may understand some of the ratio, but not very in detail. But somehow you may know, starting from the original resources to the end user, how many energy has been rejected. So such kind of idea of the ratio, being an energy manager in the future, more or less, you would know, you must know the concept. And one more thing is, I think in your manual report, no matter you are studying the power, I mean in the subject like the 710 or even 695 or other subject like 795, 740, maybe in the future, you should have a concept, because many times you will say, oh, right now for the energy consumption raised how many percent per year. So such kind of concept, I think you should know about it, and it appear in your lecture notes also. That is what I heard from Mr. Demopoulos in the video. Somehow you need to know about such kind of factor. So I just have time to go overview on the lecture notes once, because somehow you will miss something, and I hope just the very short review can refresh your memory on some of, I think, which is important. Any question on that?
No.
So, okay, good. If no, then why don't we have review some of the power factor? So, this is maybe the last lecture. I'm not sure the last lecture or the last two lecture. Some of the question, but okay, guys, the meeting will end in 10 minutes. So after 10 minutes, we will switch to the second link. Okay, if we stop accidentally, so click the second link and enter the chat room again. Okay, so some of the now, but I believe 10 minutes has already enough. It's enough for us to go over the power factor. So today I also have another tutorial about the power factor. As I remember, in last tutorial, we also touched with some of the question on that. So when we handle the power factor question, first of all, we need to construct such power triangle. It's what we call the power triangle. And we need to know for every side, what is their name, what are their terms, and what are their units. So for the horizontal one, it is called the active power or real power. It is a power which directly applied to the machine, to the appliance. And it is the energy which supplied to the machine to give you the work done. And the vertical one is the reactive power. This power is a kind of waste, but why it will create? I would say nobody want this happen, but when you, let's say when the current passing through the magnetic field, there will create another current. Like what we did in the transformer is also a kind of a reactive power we create. That is the vertical one. And I'm not sure you still remember the unit of the reactive power. That is the kVAR. kVAR. And active power is kW. And the hypotenuse, the slope line, what we call is the total power or apparent power. So the unit is kVA. So for those unit and terms, you need to understand and remember it, because like this kind of question is very obviously to ask you what is the electricity power input in kilowatt. So if you remember, kilowatt is the active power. That is what we need to obtain. Then after you build your power triangle, you can apply the geometry and obtain the number as you want, okay? So let's take a look on this question. A single-phase AC electrical load is supplied by 240 watts. It may in a European country, not in American, 20 ampere, and has a power factor cosine theta of 90% and 80%, that is 0.8. So what is an electric power input in kilowatt? So the question is very obvious, is kilowatt. So after we construct the power triangle, we can calculate the apparent power by making use of the P equal to voltage times current. Then we can obtain the number in terms of kVA. And we know the power factor. Power factor is equal to cosine phi, that also with the number 0.8. And by the geometry, cosine is equal to this sine over this hypothesis. Then we can obtain the power input 3.84 kilowatt. Any question on that?
No.
Okay, very good. Another question, which we applied the same methodology, but such type of question we are facing is three-phase instead of single phase. So let's take a look on the question. A three-phase AC induction motor runs on 380 volts is normal in the European country or Asian country. Draw 50 ampere and has the power factor cosine theta of 72%. What is the kVA input to the motor and what is the kW input to the motor? So now what we know is the apparent power 380 volt, draw 50 amp. So with the voltage and ampere, we can calculate the power. But what we need to calculate, so why the unit is so important? Because when you know the unit, you can simply know what you need to calculate from the power triangle. So kVA, as you know, is about the apparent power, and the kilowatt is the active or real power. So by a three-phase equation of the power, √3 times current times voltage, by putting all the number inside this equation, we can get the power apparent number in terms of kVA. That is the question asked. Another parameter we need to figure it out is the power in terms of kilowatt. Kilowatt, that is the real power and the active power. By the geometry, we know the slope, we know the cosine theta, then we can simply calculate the power input. Okay, any question on that?
No.
Can you explain once again the last step?
Okay.
Yeah.
So first of all, we need to know what is the definition of the cosine theta. Cosine theta is equal to, of course, here is equal to 0.72. But in the concept of the geometry, cosine theta is this baseline over the hypotenuse.
Yeah.
Okay, so
Okay.
we can calculate the hypotenuse, that the apparent power, by making use of √3 times current times voltage. Then we can obtain this number. That is
I got that part. Yeah.
Okay.
Yeah.
And
regarding the second part,
yeah, okay. So you get it, right?
Yes, I got the first part, but the second part, the 23.7 kilowatt, how do we get that?
Okay. Maybe I insert a box. Okay, cosine maybe it's theta, but I don't want to draw the equation and type. It's equal to, let's see, this by geometry, I mean, if this side is A, this side.
So if the hypotenuse is B, then A divided by B, right?
Yeah, right.
Okay.
Yes, A divided by B. And now we would like to have obtained A. So here A is equal to B times cosine theta. So that is the equation on
Yeah.
that.
Okay. Got it.
Okay. 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 So we have less than 1 minute. Get prepared. We will be cut. But anyway, remember, maybe I record. Yeah, I start here to record. Okay. So we have already finished this sample. We have another one. So be patient. This one I don't know how to cancel it, but let it 1 to 100%, and it will shut it off. And so with the same idea, we can tackle whatever value you want by the power triangle. So this time we know about the apparent power and also the real power. Then just by the same concept of the cosine, then we can get the number of power factor. But this question, I don't think I need to go in very detail. Just by the simple concept, you need to construct the power triangle and put the number in the equation, and you can get the value. Okay. So it's our second part of the tutorial. Any question on that?
No, it's good.
It's good.
Okay.
Yeah.
Yeah.
Good.
Okay, then I don't save it. Okay. Anyway, I have some trouble on the screen sharing, but no problem. Screen. So now we are going to jump to the last part. So everybody can see my screen, right? Now.
Yes, we can see. But
Okay.
it's the desktop. Yeah.
Okay. Yes. Okay. The final part I would like to share with you is how to do the regression analyze in the Excel. So I have obtained a number which you may facing the same issue when you're doing the project at the end of these classes. I mean, in these courses, or in the real case, when you're handling some of the energy audit, according to, let's say, the Asia level 2, somehow you also need to have such skill, how to make use of the data on hand. I'm not sure you know about it or not. It's very easy for you to obtain CCD or HDD through the website, but you need to learn what is the CDD and HDD about in case somebody asks you what is the HDD and what is the CDD. Do you know what is this HDD and CDD about?
Yeah, it's heating degree day and cooling degree days.
Yes, degree day. But the concept is amount of energy. Let's say the CDD light here is the amount of energy to cool the building in terms of a period, like per month, per year, per day. And here the question is per month, because we are in terms of every month we obtain the energy consumption and also the average temperature. But compared with the average temperature, we need to have the standard. We need to have the standard temperature. And this figure may be set by you. In this example, I just take 22 degrees Celsius. What does that mean? Because now we are obtaining CDD. If the temperature going up above 22, then it will count the residual or the difference on that. If the temperature below 22, the CDD will be 0. Okay, so in contrast, for HDD, it will change. If I also set the standard temperature is 22, when the temperature raised above 22, HDD will be 0. But if it fall below 22, let's say 20, then we have 2 in difference and multiply the date. Okay. So here, any question on that? Okay. If no, we can try how to obtain this number. Now we know this number is need to minus this one. And with this figure, we need to multiply by the number of days, okay? So, is this value is correct for CDD? Is the value correct? Every box is controlled by the equation. Is it correct?
I think something wrong is there.
Yes. What wrong? What is the error? Why there's an error?
Because our base temperature is average temperature is less than the base temperature.
You mean difference? I should use 22 minus 22.5.
Yes.
Yes. But anyway, it doesn't really matter because right now we are calculating CDD, not HDD. When we calculate HDD, so it will have a difference. But why I say it is not the main factor is try to understand no matter CDD and HDD is not allow you to have a negative number. Why? Because if this temperature for CDD, the concept of CDD is how much energy I need to cool the building. If the temperature is below the set point 22, I don't need to have any energy to supply into the building. I don't need to cool it because the FH ambient temperature has already below the target. So we don't need to do anything. So in this case, I would say the error is in we don't allow the negative number. At the same time, when you're doing the question on HDD, you may do the same, but your set point is in 22, but the number of the FH temperature may be below 22. Let's say you have a set of number with 15, 16, 13, then you make use of 22 minus 15, 15, then you can get a positive number. But when the temperature go up above 22, let's say 23, so you don't need to spend extra energy to heat up the building. So at that moment, the HDD will be 0. So in the same cases in here, CDD, if the temperature is below 22, we don't need to supply any energy to cool the building because the building has already been cooled by the atmosphere temperature. So do you guys understand what I'm trying to say?
Yes, we got it. But the minus, the negative value is actually 0. We should not consider it as negative. We should
Yes.
consider it as 0.
Yes. So we don't allow any negative number or opposite number, I can say.
Okay.
If you want, I like to see the negative number is my habit. You can do it, but if you the whole column negative number represent the CDD, then you are not allowed to have the positive number. So do you understand my concept or logic? Yeah, we only allow one side, no matter neither positive or negative. It depends on how you define the equation. But we allow another sign of the number appear in our table. So now we are using the Excel. If it is less than 0, then 0. Otherwise, copy this. Should be correct. Should be correct. Not sure. Let's see. So it seems correct. Yes, it seems correct. So after we obtain the number of CDD, what is the second step? Is we need to do the regression. Somehow, what I try to say is, you are very easy to obtain the CDD or HDD because you can obtain this from internet of the government or the observatory department. So you can obtain this number, the weather number, the value is very easy. But if you need to obtain energy consumption, somehow it's difficult, it's more difficult. So what we try to do in regression analysis is we need to know if the energy consumption and the data we are easily or easier to obtain, if these two set of data, there is any relationship or not. So I believe recently machine learning, such kind of the terms you are quite familiar with, and eventually the regression analysis is a kind of algorithm. Before we know if I can define this and that, we need to obtain the data. Throughout the data, we need to know these two data sets, what is the relationship. So here, we just one purpose for the linear regression, the name linear. That means if they have any linear relationship between two sets of data, one is the energy consumption, another one is the weather. Okay, so let's take a look on column B. In the column B, there are two categories. One is the baseline, another one is the post-retrofit. And what does that mean? The baseline is what you have already know about the data, and the post-retrofit, that is after you make something different, after you improve like the boiler, like some insulation, some building envelope. So it is the post-retrofit. But everything we need to take something as a baseline, a standard value. If I do the improvement, what is the difference of the energy consumption? That is what we need to do in Q-sum in the later step. But first of all, we need to obtain the relationship between the energy consumption and the CDD. So in the Excel, it is quite easier. Before I start how to operate the Excel, did anybody try to using Excel to obtain the regression analysis? Anyone have already tried? Yes or no? No. Do you guys try to use the Excel to perform the regression analysis?
No, like we're having issue with this one. we didn't know how to do it.
Okay. So
In my BTech, in my graduation, I make a graph regarding
oh, you have already tried it, right?
but not this
Okay.
thing in my graduation. Some other data, some other subject.
Okay. So you also use the Excel, or you use some of another program language?
Just Excel, just simple graph. Yeah, just simple graph we make and we make a correlation. That's it.
Okay.
A little bit different from this.
Okay, never mind. Maybe I do in my way, because even in Excel, there are many different kind of method or different rates to obtain the same number. Let's see. So before you open such kind of function, you need to know one thing: the add-in function. Let's see, where is it? Okay. Okay. So before you need to apply the function of the linear regression, try to search, because now I'm using the Mac version of the Microsoft Excel, but in the Windows version, this option, this tick box, will have in different places. So in Mac version, I try to pick the name of add-in and make sure analyst toolpath is clicked and deployed. Otherwise, you cannot use such analyst function. In the Windows version, as far as I remember, is something like in the Excel and in the setting. But if in the coming time you find difficulty to find this tick box, please feel free to contact me. So after you make sure this function is deployed, and go to the data analyst. Here, you may find a different method on the data analyst. Now, we are doing the linear regression, so we click the regression. So in the regression, we need to obtain the value. There's two set of data. One is Y, one is X. Y is the output. That is, in the future, if I want to predict something, what kind of data we need to have? That is the Y. X is the input value. In this case, as I mentioned, it is easier for you to obtain the CDD or HDD. This weather value is very easy for you to obtain through the internet. But if you want to predict the energy consumption of this building, I don't think it will so easy to get it. So why will be the energy consumption? That is what we need the output in the later time. And next is what data you are easy to obtain. So the Y is the build energy consumption, and we just use a baseline set of the data. That is, we take this set of data as a reference to see this period of the data, if those data can find out the relationship. So the X is CDD and the baseline here. And there are some checkbox. Normally, I will click it all, except the constant is 0. So what is meant by the constant is 0 is the graph will show you the line will touch the 0 and 0 origin. But it may not apply that in our cases because the y-intercept may not be 0. So I will leave it open and not click it. So after you input the column of the data and take the information you need and present to you, then press OK button. Then you will know, you will find a table and some of the graph. In order to not confusing you, we mainly just take a look on this graph only. Okay, but before we look at the graph, let's see some of the parameter. What is it about? So multiple R. Multiple R, this value is to show how strong the linear relationship. Most likely, this value is range from -1 and 1 to 1. And -1 to 1, that is this value represents a very strong relationship. But for 1, it's direct proportional. -1 is inversely direct proportional in different slope. One is with a proportional, one is inverse proportional. So another parameter is R square. R square, we also call it is a coefficient determination. That is a kind of the R represent the variance, the variation. So R simply is the value on for the every linear, I mean the production line and the actual value. What is the difference? And R square is something like the variance. So in the concept of the mathematical statistic, something like the variance. And here there is also a adjusted R square. For this value, in this case, it may not apply. Most likely for adjusted R square, when we're facing more than one parameter, we need to find out the relationship, and we need to make use of this. But this one, we just have 1 and 1 only. 1 is the result, 1 is the input. I just have 1 input, so we don't need to take care so much on this. And the standard error is this value is when for the value, most likely if is the what we have the predicted curve like this one. I may draw a curve to you first, otherwise it may a little bit confusing. If yes, so this is also very important step. This data is what we input in the table, and this trend line is what we need to get and what we need to learn from this. Yeah. So we need to display the concept, the equation. This learning. Okay. So what is the error? Is this line is obtained by finding out the relationship with every point and draw a straight line. And it seems this straight line can represent this set of data. So how many number we construct this line is 12. We make use of 12 data, 12 point to construct this line. Okay, another quite important concept is the coefficient. So you may see that these represent the line. So for the straight line, we can simply say y equal to mx plus c. M is the slope and c is the y-intercept. So here if I would like to present this equation. Oh, here we have the equation. The slope here is 12.95 here, and the y-intercept is 1,803. That is the equation we obtain from the method of linear regression. Okay, so any question to obtain this graph so far?
Once again,
Sorry, I can't hear very well. Sorry. I beg your pardon?
can you explain once again y is equal to mx plus c? So
Okay.
from where you got that c 1803.9 the value?
Okay. This is a kind of method which make use of a data set to find if there is any relationship between every point. So by this kind of method, we can obtain this equation. But how we can obtain this equation is by the algorithm, of course. But what if I do the input again? How I can obtain this equation? We need to have the value on on this one. This number is a slope. I'm not sure you still remember y mx plus c. This is the equation represent a straight line. M is a slope, and c is the y-intercept here. So these two numbers simply represent this one, intercept is a y-intercept. So this number will represent here instead of c. And this value, 12.95, it's a slope, that is m. Okay? Okay, can I understand? Can I answer your question?
Yeah.
Okay. So we know about the relationship. Yeah, it is a relationship. And also, this number is pretty good because as I mentioned, the multiple R represent how strong the relationship it is. Maximum is 1. So now we are trend to 1. So this value is very good. Those data can greatly represent it is a linear relationship. So now we know about this value, and we have to build it energy consumption. Build it, that means you consume the energy actual you consume. It's not predict, it's consumed. But before I know about this value, because this value is you actually consumed, so you receive a bill from BC Hydro. You know how much energy you actually consume. But if I would like to know for the improvement in the post retrofit, is it valuable or what is the efficiency? We need to have a comparison. How we compare this actual energy consumption is in the real case. But the baseline is we make use of the period that I haven't made any improvement as a comparison. So guys, another 10 minutes. So after 10 minutes, if I still need to talk something, then go to the third one, okay? So let's see how we can obtain the predicted energy consumption. As we have find this kind of relationship, now we can construct equation like that. So by this equation, y is the energy consumption, x is the CDD here. So if I know the value of CDD, then we can estimate the energy consumption. We should have this concept. So by the equation of the predicted energy consumption, Y is equal to mx, right? M is the slope. So the slope here is this one. But of course, we don't have any choice. We put the dollar sign to fix this box and don't let it to go away. And times X is the HDD, okay? HDD is here, but it needs to move. It is changeable, so I don't put the dollar sign over there. And plus the y-intercept. Y-intercept is this value, and also it is a fixed value. So I put the dollar sign, okay? So the first value, 2,285. And those energy consumption is predict energy consumption. That means we only make use of the previous year's data to estimate or to predict. If the CDD is 37.2, what will be the energy consumption? Okay, so anybody still have a question on the predict energy consumption, on how to find it out and why we need to find it out? Anyone? Any question? Okay, if no, we need to know the difference. So the difference is the actual energy consumption minus the predict one. Predict one is based on our baseline. That means before we make any improvement, before we retrofit it, what will be the energy consumption? But eventually, we have made the improvement. So if the value of the residual is negative, that means we have the energy saving. On the other hand, if this value with a positive sign, that means we are not doing the energy saving. We consume more energy instead. Okay, any question on that?
No.
Okay, very good. So the last column we need to build is the Q sum. Q sum is a accumulate value. Let's see the first month, then I have the first month value. Second month, I will have the first month plus the second one value. So here, we just simply do the addition with these two numbers, and this one is here. So by the equation, it is a powerful of okay. Have something wrong. Oh, yes, I have something wrong. Check. Okay. So this accumulation of every month the residual value. So as I mentioned, if we can obtain the negative value, that means we have the energy saving. More highest value on this negative value, that means we saving higher value of energy consumption. So normally we will plot this curve by the Q sum and the month. Yeah, we can obtain this value. So during some of the question in your, maybe in your quiz or in your exam, you need to know, you can explain about this curve. So one thing you need to learn is if this value is negative, that means there is the energy saving. Higher slope of this line, that means higher energy you have already saved. The higher energy saving you obtain. And steeply, the curve is flat. That means there's no big change on the improvement or not. But if the curve on the opposite side with a positive slope, that means you are not saving the energy. You consume more energy than in the past. Okay. So any question on how to obtain the Q sum with set of data of VA2, which in the calculation on the predicted value and the actual value of the energy consumption? Any question on that?
No, but like, do we need to calculate for baseline or not?
Actually, for those data, you need to have, otherwise you cannot build your linear regression equation.
Mm-hmm.
Okay, but what you need to know the skill is how I make use of this set of data to obtain this equation.
Oh yeah, I got
okay.
it. Yeah.
And make use of this equation and input the value of HDD or CDD, or sometimes in some of the question, it may not relate to the weather. Maybe the energy consumption relate to the quantity of your production output. Then it may be also the case. It depends. So after you obtain this equation, by putting those variable to obtain the predicted value.
I got
If
it.
the predicted value is lower than the actual value, then you did a great job. You do something which improve the energy, improve the performance, and saving the energy. Okay.
Yeah.
Okay. So, any more questions?
No.
Just
Okay.
one more time, can you explain the predicted value in place of y, what we are putting, and mx plus c? So what is c, what is y in the predicted energy consumption?
Okay. Predicted value is we can obtain from this equation.
Yeah.
And how we can obtain this equation is by putting the output of the data analyst, the value of intercept and the slope. We can have this equation. Okay. And actually, what we have done in this Excel file is we putting this. Let's say this one. We take this x as x. We put 372. 303. Sorry, 37.2 times this value and plus this value, and we obtain this predicted value. Okay.
Okay. Yeah.
Okay.
Got it. Thank you.
Okay, you're welcome. So I think that is all from today, and we have less than 1 minute. Any question, please feel free to email me, and we can keep it.